A car park agent is a camera connected to a Raspberry Pi running one of our programs, which we call an agent. And the idea is that it looks out at car parking spaces and determines how many are available to park in. So this is obviously like valuable, useful information, and it makes this information available on the Fetch.ai network for other agents to then buy for a small micropayment. So these other agents might be something like say a GPS app that's trying to direct a driver to a parking space near to their destination. And so this is a very simple demonstration of the power of the Fetch.ai network. We have an autonomous agent running in this camera Pi setup, gathering valuable information from the real world, and then using it to create a revenue stream for the person that owns that device. And then at the same time, we have these other agents using that valuable information, buying it, and then offering a valuable service to the driver or whoever owns them. And as more of these agents come online, for example, delivering information about, say, congestion or restaurant opening hours and reviews and wait times or weather, then all of this information available on the Fetch.ai network can be utilized by these digital assistants to offer more and more value to the people that own them. Fetch.ai is not a car park monitoring company or indeed a computer vision company. All those aspects of the car park agent, we've just used off-the-shelf bits of software. So for example, we use Google's TensorFlow to do the car detection aspect of it. So what Fetch.ai offers is an economic platform that allows individuals and companies who do make these kinds of devices to connect to, and these devices can then find each other, communicate, transact in a mutually beneficial way, which overall increases the value that these devices can offer to people. So they can feel also safe in the knowledge that the platform is all open source and decentralized, meaning there's no one single organization owning it. And that means that overhead costs are kept to a minimum, and it will continue to serve the interests of the people actually using it. Well, you can actually make one of these things yourself. There are instructions on our GitHub page which take you step by step how to build it, install the software, configure it, and so on. There's actually also a video which shows me making one, so you can watch that and follow along as well. Once you've got the car park agent installed on the Raspberry Pi and running, there's a user interface which lets you see what the camera is seeing as well as other information. And you can then use this to define an area of the scene that you're interested in, which is the area where the cars are going to park. And then you specify the maximum number of cars that could possibly park there. And then at regular intervals, the system captures an image, detects cars in that region, counts them, and then subtracts that number from the maximum number of cars that could be there, and it says, well, that's the number of parking spaces. And that's the information that's made available on the Fetch.ai network. On the Fetch.ai network, agents can trade things of value, say data in this case, or services, with other agents in exchange for something called FET tokens. So FET tokens are a currency which is internal to the Fetch.ai network. Car park agents have this valuable data, this information about how many parking spaces are currently available. But they have a whole load of other information that they need to share as well. So the way it works is that they register onto the network and they share their location, how many spaces they are reporting about, like what's the maximum number of spaces that could be there. Also when they last made a detections. And it's got the price here, which is basically it looks like a big number, but it's a tiny amount. It's a fraction of a pence. So they share all that information on the network. So other agents can then search the network for this kind of data, and they can look and say, okay, well, these are this is in the area that I'm interested in. The price seems about right. Yes, okay, give me the data. At which point the transaction takes place, the car park agent sends the number of available spaces and the other agent sends the Fetch tokens to the car park agent. So we use the Raspberry Pi 4 because it has a good fast processor and crucially a lot of memory. So you can have 4 gigabytes of memory on the Raspberry Pi 4. And that is needed to run these quite heavyweight computer vision algorithms such as Google's TensorFlow. So it lets us run these algorithms whilst also maintaining a nice responsive user interface as well. With the way that we've got things set up at the moment, when one agent requests car parking data from one of our car park agents, it just requests it, the data is sent, and the car park agent just has to trust that the other agent will send the Fetch tokens in return. Now, the car park agent does keep track of all of the data it's sent out and whether it's actually received the Fetch tokens that it was promised, but it can't really do anything about it if another agent just decides to not pay. Also, the car park agent doesn't really make any attempt beforehand to decide, is this other agent trustworthy? Does it have a history of good behavior in the past? So none of these components are there yet, but these are very active areas of development at the moment within Fetch.ai. So the first thing to do is to make sure that the value exchange is done through one of our synergetic contracts. This would enforce that the car park agent supplies the data, the other agent supplies the Fetch tokens, and only when both things have been done will the two agents get the things that they've asked for. So that's one part of the solution, but that doesn't solve it completely because the car park agent could just be giving out random rubbish data. Maybe someone's just holding up a photo of a car park or something to a camera. So the other part of it is to ensure that agents can effectively write reviews of other agents, give them a star rating, say, yes, that was a good transaction. Collectively, these will build up a reputation for an agent over time that will be stored on the blockchain. So before you start communicating and transacting with another agent, you'll have a good idea of what their past reputation is like. We're working with a company called Sovereign, developing this service called Anvil, which will allow an individual or a company who develops one of the Fetch.ai agents to give that agent a certificate which effectively guarantees that that agent belongs to that individual. And by doing that, any reputation that that agent starts creating isn't just tied to that agent, it's actually tied to that individual or that company. And by tying it to real world entities, you start to get like a sort of persistent, meaningful reputation developing. One of the things we've found while developing this is that, sort of as with nearly all computer vision algorithms, the car detection doesn't always work perfectly, and to some degree this is just the nature of computer vision. It's never going to be perfect. But also the training set that we've used was actually, I believe, created using like dashboard cameras. So it's not ideally suited for actually detecting cars in a car park. And I suspect a much better model could be created if we actually used training data of parked cars in car parks or on the streets or whatever. So if you are setting this up, usually you can make things better by just moving your camera to a better vantage point. Research has shown that a large proportion of the congestion in city centres is caused by people driving around looking for parking spaces. So if we can just start to get this kind of data out there, available on the network for other apps to use, ultimately that's going to cut down wasted journeys, which is going to reduce congestion, reduce pollution, and ultimately improve people's lives.